Okay, in this video we're going to go back and discuss parallel and perpendicular lines, which we talked a lot about over the course of the year. However, now we're going to deal with them in a coordinate plane, which means we can estimate what we think is happening, but we really need to calculate it to prove whether or not we're actually correct. So if I was asked, the line between these red points that connects those and the line that connects the green points, are those two lines parallel, perpendicular, or neither one? Okay, now, just by looking at this picture, are they parallel? Well, obviously no. Parallel lines are moving the exact same direction, and these lines cross. So if two lines eventually intersect, they can't be moving the exact same direction. So I could say parallel, yeah, you know what? Parallel, in this case, I can tell that's not it. However, sometimes they look so close in your drawing, you just can't necessarily tell for sure. So I'm going to show you how to deal with the numbers to make sure you know what's happening. Now, perpendicular? Yeah, it's possible. I mean, that could be a 90-degree angle there. It's kind of hard to tell from our drawing because our drawings are never perfect. They're always kind of a rough estimate. I think they could be neither. They could just be both moving at these different slopes, and there is no relationship there. So let's jump into the slope values to figure this out. Okay. So let's start with the red ones. If I was going to find the slope of that red line, I would take my y values and subtract them, my x values and subtract them. And what I'm going to find is I end up with 3 over 2. 3/2 is my slope, and it's a positive slope. It's climbing as we go this way, so that looks like it matches. You always want to see if your numbers make sense in a picture. Okay, if the two things match, you probably don't have any mistakes to worry about. Now, if I were to calculate the slope of the green ones, oops, wrong color here. If I were to calculate the slope of those green ones right there, and it ended up being exactly the same, then no matter how bad my drawing is, if the numbers tell me they're exactly the same on their slope, it would have been parallel. Now, obviously from my drawing, it can't be that bad. I can tell it's not going to be parallel lines. Let's see if there's a relationship to make them perpendicular. Okay? Or maybe they just aren't either one. So if I look at my green ones, I had -5, 1, 5, -1, and 2, +1. So let's take the y values and subtract them. I get -1 minus 1. Then I take the x values and do the same thing, and I get 5 minus 2. So I end up with -2/3. Okay, this time it's a negative slope. Now you look at these two values here, they do kind of look the same. There's a relationship there. They are opposite reciprocals. Okay? And if you ever get two slopes that are basically one is negative, one's positive, and the fractions are just flipped, and that's it, everything else is identical, then that tells you it is a perfectly perpendicular scenario. That's exactly 90 degrees. Even though my drawing looks a little bit off, the numbers tell me it has to be perpendicular. So these two sets of lines would have to be perpendicular.